You may have noticed, perhaps I should have mentioned in the first session, but I'm having trouble breaking my lifelong habit pretty well since I was about 20, I think. I've always been pretty much a night person, and once I finish writing up the board and filming and pre-processing and uploading, then I do other things, and mostly it's looking at advanced text and mathematical physics and so forth, and then the night drags on, and I'm reluctant to go to bed because I've been doing that for decades. So, but the downside of that is then if I go to bed too late, I wake up late, and then I run out of daylight to film, and that's what's been happening quite a lot. And I should, for several reasons, film during the day, do the whole board during the day, in daylight. One is it makes the text more visible, and the other is it's better for my eyes, I think, because my eyes feel somewhat strained. Perhaps too much time looking at computer screens, or perhaps the peripheral vision of my retina has been strained by having too bright lights concentrated in one area rather than diffuse daylight. So for both those reasons, I need to be more disciplined about going to bed on time so I can get up early enough to complete the filming in daylight. All right. Okay, so this section now, decidable languages. And given what I was saying in the previous session, we're going to create, and it'll be a theme for. Well, be more next session. I'll spell it out more explicitly. But one of the themes, main ideas of this board is that we're going to take particular problems and put them, like translate them if you like, into a language type problem, and a bit more specifically membership of a language. Remember a language is just a set of strings, right? So we will translate a problem into a string and then check if that string belongs to the language, and if so, then we can solve a particular problem we're interested in. Now that may sound rather vague, and it will become more concrete as we get into it, because we'll be doing it. I think there are like 9. Let me check. I think there are like 9 theorems doing this kind of thing, where we show that we take a particular problem and translate it into a language problem, membership of a language. And how many theorems? Yeah, there are 9 theorems doing this. So by the time we finished it, you should have a pretty clear idea of this very general technique of expressing a problem in terms of a language. There are 9 theorems. We'll go through this process 9 times before we get to the second section, which is on the halting problem. And even there, it's still the same. But we're showing that the language is not decidable. So there's another. How many more theorems? 1, 2, and a corollary. 3, 4, 5, 6. Yeah, well, a lot of what was it? 9, 6, 15. About 15 or so theorems on this idea. So a very important idea, and I'll be ramming that point home next session. Okay, so decidable languages, the main theme for this section. So we'll be giving examples, and we'll do 2, I think, on this board, our first 2. Examples of languages that are decidable. Remember, well, I've said this several times, but just a bit of quick revision. A language is decidable if what? It means if there's some Turing machine, some algorithm that accepts every string in that language and rejects any other string. Okay? It's the Turing machine is a decider, and a decider by definition is a Turing machine that decides. It either halts by accepting or it halts by rejecting, but it always halts, right? It never loops. Halting and looping are the opposites of each other. So a decider never loops. It always stops eventually. It halts by accepting or rejecting. All right. Okay. Now, for this chapter, we're going to concentrate on languages that are related. And I'm still being a bit vague, but you'll see what I mean as we go through it, example by example. So we're going to concentrate on languages that are related, connected somehow, with problems about or concerning automata and grammars. For example, here's a problem relating to a grammar. If, for example, we're going to use an algorithm to test if a particular string belongs to a context-free language. Okay. Now, why do such a thing? Well, several reasons. One, it's very useful. There are applications where this is done. For example, in compilers. We talked a lot about compilers, so I won't go into that again. Right? So you want to know if a particular string can be generated by a given grammar. Remember, a context-free language is the set of all strings that can be generated by a CFG, by a context-free grammar. Okay, we've done that at length in earlier lectures, earlier sessions. Right? So it's useful, doing such a thing, solving this kind of problem. Does a particular string belong to a particular language? That has very practical implications in computer science, particularly with compilers. Right? So it's the string, recognizing the string, and used by compilers in computer science. And let's see, now there are other problems, like the halting problem would be a famous example of one, but there are other problems. Remembering what I talked about in the first session, there are problems concerning automata and grammars and so on that are not decidable by algorithms. In other words, there's no algorithm that can decide that language. And what would that mean then? Well, the algorithms that you apply to that language, there may be strings in that language which cause the algorithm the Turing machine, to loop. Okay, does not decide, may loop. All right. Okay. Now. So what we're going to do, we're going to start with examples where decidability is possible. We're going to translate language. We're going to translate problems into languages. Express the problem in a kind of language-like form, asking whether a particular string belongs to a particular language. So we can by doing that, we can translate a computational problem, automata type problem, grammar type problem, whatever. We translate it into a string. I'm getting a bit more concrete now. So we transform the problem into a string, and then we ask whether the string belongs to a particular language. And